And finally, in section 5.5, we deal with polynomial and rational inequalities. This is a nice conclusion to our chapter 5 work in terms of everything we've done with our polynomials and rational functions. So example 1 gives us two pictures, two different graphs. One's a polynomial and one's a rational function. And they're going to ask us some questions about these two pictures. So they want us to use the graph of the function to solve the inequality. So if this is our function f of x, we want to solve f of x is less than or equal to 0. So what this is asking us is, where is the y? Where are the y values of the graph below the x-axis? We want to know where the y values themselves are negative. That's what this is asking. Where's the function negative? Well, the function is negative any place that's below the x-axis. So this particular picture is below the x-axis, between -1 and 1. So that's this bottom bump down here. We're going to use brackets because the inequality is an inclusive one, but it's also below the x-axis from 2 to infinity. So within these intervals are where we see negative y values. Notice that the answers are written in terms of x only. Does it really matter where the y-axis is to discuss this equation or this inequality? It doesn't. So the y-axis is pretty meaningless, as is that y-intercept. What we really need are these x-intercepts to determine where it's above or below the x-axis. The second part to that question is asking f of x greater than 0. So again, this is asking me where the y values are. And in this case, because it's greater than 0 positive, that would be above the x-axis. So if we're greater than 0, we're looking for positive y values, and positive y values lie above the x-axis. So for this particular graph, this graph is above the x-axis from -infinity to -1. We're going to use an exclusive parenthesis because the inequality is exclusive of the 0. It's also above the x-axis between 1 and 2, so from 1 to 2. And that's how we solve these polynomial inequalities, which is wonderful if you're given the picture or the graph of that function. Okay, let's do the rational inequality. It's the same kind of conversation. We do have to watch out for those vertical asymptotes, though, so be careful with those. So the first question over here is asking for f of x less than 0. So y being negative. So where are the y values negative? Wherever the graph is below the x-axis. So this graph is below the x-axis from -1 to 0. And it's also below the x-axis between 1 and infinity. So this piece of the graph is below the x-axis. Now, the inequality here does not include the endpoints, so there's no issue. So we're saying that the graph is below or has negative y values between -1 and 0, and then again from 1 to infinity. The second part of that question is asking for when f of x is greater than or equal to 0. So now we want to know where it's above the x-axis. Well, it's above the x-axis over here. So that would be from -infinity to -1. It's also above the x-axis between 0 and infinity. I'm sorry, be careful, between 0 and 1. So 0 and 1. And notice again, we can walk through the picture just like we did in earlier interval notation when we talked about increasing and decreasing, right? We can walk through this picture. So from -infinity to -1, the graph is above. Between -1 and 0, it's below. Between 0 and 1, it's above. And then from 1 to infinity, it's below. And that takes care of a rational inequality. So in order to solve, we've listed the steps. These steps are taken directly from your textbook. So the first thing you have to do is make sure you write the inequality in the correct form. You have to compare it to 0. So that's because this analysis is depending on whether or not you're above or below the x-axis for less than and greater than kind of thing. So you have to compare it to 0. Determine the real numbers which f of x is equal to 0. Those would be the x-intercepts. Or where the function is undefined, those would be a vertical asymptote. So we're going to call those boundary numbers. We need the boundary numbers. These boundary numbers are where the graph will either change the sign or have a vertical asymptote. Use the numbers in step 2, those boundary numbers, to divide the real number line into intervals. Then we're going to select and test a number in each of those intervals. We're going to basically build a sign tree. So